So we're looking today at the idea of doing multiplication using an area model. And the reason this is popping up is I've been watching a Facebook thread from a number of very frustrated parents who are suddenly having to teach their children multiplication in a way different than what they learned. And they're feeling like, wow, this new math, it's so confusing. Why are they doing this to my kid and to me? Before I get into how to do an area model, let me just say thank you to all the parents out there who have suddenly been put in the position of being math teachers. You have that unenviable role that often a guest teacher has, or a sub has, coming into a room where the class has been doing something for a while and you're dropped into the middle of it and asked to pick up the lesson. That's what this pandemic has done to us. And so again, as a middle school math teacher who always appreciates the efforts of parents working with their kids, thank you. All right, so let's talk about this and why it's not a better way or a worse way than what you learned, what we call the standard algorithm, but it's a different way and it has some different purposes to it. So if we take a standard math problem, standard multiplication problem, let's multiply 14 times 35. The standard algorithm is to take the 14, put it on top of the 35, and start multiplying places. 5 times 4 is 20, carry a 2 because you can't put more than one thing in a column. 5 times 1 is 5 and 2 more makes 7. Then save a place here because when we multiply this 3 times 4, we're not multiplying actually 3 times 4, we're multiplying 30 times 4, 30 groups of 4. That's going to give us 120, but 3 times 4 is 12, carry a 1, 3 times 1 is 3, 1 more is 4, and then add the columns and get 490. Now, if you were looking at that problem, you were thinking, I would never think of all those parts. I don't have to worry about it's 30 groups of 4, not 3 times 4. Absolutely. And you've done this math a lot, and you have your understanding of how to do it. And this standard algorithm, that's what we call this method. This standard algorithm is something that's become very natural for you. But that wasn't the case when you first started. And what we're trying to do with the area model is explain to kids why multiplication works. It doesn't mean they're going to use this all the time. In fact, I would venture to say that most of you don't use the standard algorithm all the time. You grab the phone out of your pocket, open the calculator app, and multiply away. But we want kids to understand the foundation of multiplication. So to do this problem, 14 times 35, we would build a rectangle that looks like this. And we would divide it, the top or the columns, into 2 columns because we've got 2 parts. We've got 10 ones, or 1 10, excuse me, and 4 ones, 14. And we'd have 2 rows because we have 3 10s for 30 and then 5. We would then start multiplying these parts. We call it an area model because it fits the idea of finding the area of a rectangle. If you find the area of any rectangle, you multiply the length times the width. This would give you 6 square units, either inches, centimeters, whatever you're working with. Think of this model, if you were buying carpet for a house and you had 4 separate rooms, you would need to find the area of each room to figure out how much carpet to buy. That's what we're doing here. So 30 times 10. So 30 groups of 10. 3 times 1 is 3, and then we add those 2 zeros. This is also helpful in teaching students that when you're dealing with large numbers like this, you can go ahead and multiply the leading digit if everything else is 0, and then add the zeros in. 30 groups of 4, or 4 groups of 30. That's going to be 120. Another place that this is useful is starting to build that idea of multiplication being commutative. It doesn't matter whether I think of 30 groups of 4 or I think of 4 groups of 30, I'm going to get 120. Now, if you're dealing with elementary age kids, the math teacher might not be using the term commutative. They might simply be saying, when a kid says, wait, if you do 30 times 4, can't I do 4 times 30 and get the same answer? You're right. Multiplication, it doesn't matter what order you do it, you're going to get the same answer, the same product. We'd keep going. 5 times 10 is 50, and 5 times 4 is 20. And then, just like if we were finding how much carpet we need for those 4 rooms, we would add those 4 individual areas together. So this also helps reinforce the idea of geometry, where you're finding the area of a rectangle or the area of a complex figure built out of small rectangles. One of the things we're trying to do in math these days is not make everything a one-off. We teach multiplication over here. We teach area over there. We teach addition over that place. Putting all of these together helps students understand that mathematics is really a combination of all of these tools to solve problems. So then we'd go through and we'd add these. All those are zeros. 0 and 2 makes 2. 5 more makes 7. 2 more makes 9. 3 and 1, 490. And yes, you're at the same place. Now, for those people who say, well, yeah, I'm at the same place, so why in the world do I need to do all of this? Or why does my child need to do all of this? And again, the purpose is different. The purpose of this is to help build that conceptual understanding of what's happening, to start aiding in mental math. Oh, if I've got 3 groups of that, I've got 300, and then I can think of having another 120, that's 420, and another 50, and another 20. And the point of this is to find a product. And again, as I said, most people aren't doing this. Most people plug that into a calculator and get 490. All right, let's do one more with a larger set of numbers. So we've got 297. We're multiplying by 86. So we're once again going to build a rectangle, and you can always build that large rectangle to start with. We're going to divide it into 3 columns because we have 3 different place values. We have 200, 90, and 7. We're going to divide into 2 rows because we have 80 and 6. And we're going to go through that same process. 8 times 2 is 16, so 80 times 200 is 16,000. The 2 times 8, 16, and the 3 zeros. 8 times 9 is 72, so 80 times 90 is 7,200. 80 groups of 7, or 7 groups of 80, 560. 6 groups of 200, well, 6 groups of 2 is 12, so 6 groups of 200 is 1,200. 6 times 9, 54, so 540, and then 42. Add those parts. Now, what I tell my students when it comes to adding the parts is look at this lead digit in each case. And that lead digit in each of these will tell you which order to pull the numbers out. So I'm going to start with the 16,000. It's the biggest number. Then I'm going to take the 7,200. Then I'm going to jump down to the 1,200. Notice I'm doing my thousands. Then the 560, the 540, the 42. Now, I would get the same answer if I had added just 16,000, then 7,200, then 560, then 1,200. I find for students this is easier when it builds like this sort of a funnel look, but it doesn't matter. And there's a place again for teachers to reinforce with students that addition is commutative. The order you add things in doesn't matter. You'll get the same answer. You'll get the same sum. Add all the ones places. Add all the tens. 6 and 4, 10 and 4 more make 14. Add all the hundreds. 3, 5, and 10 more is 15. Add all the thousands. 7 and 7 makes 14, and 1 makes 15. Add all the 10,000s. We get 25,542, which is exactly what you would get if you plugged this number into a standard algorithm. if you went ahead and did this multiplying. 2, carry a 4, 54, 58, carry a 5, 12, 17, hold a place, 6, carry a 5, 72, 7, carry a 7, 16, 7, 23, add them all together. Same answer. So yes, if you're thinking they're making my kid do this because it's a bunch of extra work, this is a whole lot easier. Well, yes, it's easier for you. And yes, if you tell your child, hey, you can just do this, that's a whole lot of extra work, then that's exactly the message they'll get. This is a lot of needless work. The value of this, again, is helping them understand how place value works. It's also a precursor for something we do in middle school math and high school math called multiplying polynomials. And I'll get there in just a moment. The other thing that your child's teacher might do at this point, and that you could do at this point, is you could help your kids look for the reasonableness of answers. So this, if you put the wrong numbers into the calculator, you'll get the wrong answer. But often students say, wait a minute, it must be right, the calculator said so. So this is a great place to practice some estimation. If I multiply 300 times 90, if I round both of these up to a comfortable set of numbers to use, 3 times 9 is 27, I've got 3 zeros, I know that I need an answer that's around 27,000. It's going to be less because I rounded both of my numbers up, but it's going to be around 27,000. If I do this multiplication and I get 40,000 something, or I get 15,000, I punched wrong numbers into the calculator. It gave me the right answer. There's a saying in computer programming, GI-GO. If you put garbage in, you will get garbage out. If you write the program wrong, it won't do what you want it to do, but it'll do what you told it to do. Okay, so one more place that we use this is the idea of multiplying polynomials. So these are polynomials, and polynomial multiplication is something that students start seeing in more advanced math. And you might say, I got all the way through school, never learned this, or learned this and have forgotten it, and I have a great successful life. And that's true, and that's great. One of the things we try not to do when we're teaching math in middle school or in high school is to decide for students what they're going to use and what they aren't, and only teach them what the crystal ball tells us they will need in the future. They won't necessarily know in middle school or high school what career they're going to pursue and what kind of math they might need. So we try to ease them into understanding what can sometimes be difficult concepts. If you learned this in school, you might have learned what's called a FOIL method, first in, first, outside, inside, last, multiplying all these parts. And that works, and I'm not going to go into that here. You can find a lot of videos on the interweb about the FOIL method. But I'm going to show you how what we were just doing is a build for a more comfortable way, and I'm being judgmental. I don't find the FOIL way particularly comfortable, but the area model for this becomes fairly comfortable. And we're going to bring down each of these parts. Notice again, because I had 3 parts, I built 3 columns. And here I'm going to put in the signs of what's happening because it's going to help me decide the positive or negative value of these. Coming down the side, I've got 4x and 6. And now I can multiply again using an area model. 4x times 2x squared, well, 4 times 2 is 8. X times x squared is x cubed. 4x times 3x, 4 times 3 is 12, and x times x is x squared. 4x times, and we're taking 5 away, and what I always recommend to my students is think of that as a negative 5. So 4x times negative 5, 4 times negative 5 is negative 20x. 6 times 2x squared. 6 times 2 is 12, so there are no x's here, so we just bring down the x squared. 6 times 3 is 18. Bring down the x. 6 times negative 5 is negative 30. And then we go through and we add all of these together. And in many cases, let me change up colors there. In many cases, the easiest way to think about that addition is look at things that have the same exponent with the variable. So look for what we call like terms, terms that can be combined. So my final answer here will be 8x cubed, or 8x to the third power, a 12x squared and another 12x squared, 24x squareds, an 18x and a negative 20x, well, negative 20 and positive 18. 18 of these cancel out 18 of those. We're left with 2 negative x's, and then we're adding another negative 30. And we always point out to students that that can also be written without the negatives by saying if you're adding 2x, negative 2x, it's the same way as taking away positive 2x. And if you're adding negative 30, it's the same way as taking away 30. That might have been a lot more than you wanted out of this. But again, I wanted to show you why this becomes easier to understand later for students if they've done this and they've done this. So anyway, that's the area model for multiplication. It's not something teachers have students do with every single problem. Teachers eventually move students to the standard algorithm, but when they do the standard algorithm, they have a greater understanding of why, for example, you have to hold that place open, why we can't put a number here because we're not multiplying 3 times 4 and getting 12, we're multiplying 30 groups of 4 and getting 120. So again, let me just close by saying parents who are suddenly math teachers, not by choice but by the presence of a virus, thank you so much for all the work you're doing for your kids, your teachers. We know you appreciate us. We really appreciate you also. All right, and if you have any questions, feel free to reach out to me. I'm always happy to answer questions.